Hello all together. We are Annika and Matthias. We are a part of Freifunk Munich. It's a local community of Freifunk, and their main idea is to kind of provide Wi-Fi access for the people. But during COVID-19, we as tech guys thought we might provide a conference system, and today we are going to tell something about what challenges we faced during that time. We who are presenting, it's Annika Wickert, she is senior network engineer at a German IPTV provider, and me, Matthias Kesler, I'm working mainly as an IT consultant, so I plan, build infrastructure for customers, and sometimes even develop components for that. And this comes out quite handy in the things we did during that. So we are both the people who kind of plan, built, and maintained the most part, at least, of the infrastructure of FFMUC, and we as well implemented Jitsi. So Jitsi, for those who don't know it, it's a open source conference system, and we had the so why we set up Jitsi mainly. We are doing a regular meeting in our community to talk about the newest updates and what happened. And we faced the issue that the upcoming meeting was about to get cancelled. And so we thought of different approaches. Before Corona, we had a situation that sometimes people were off-road and joined by a Nextcloud talk, which we set up as well in our infrastructure. But we faced the issue that they are at around 6 people. They are some limitations. So we looked for other solutions, and then we looked at Jitsi. The architecture seemed quite straightforward and easy to scale, and so we thought we should give it a try. And as the installation is quite simple, just an apt install Jitsi Meet and it's done. We tried it this way. We as well looked at a big blue button, but at that time, at least, it wasn't an old state of Ubuntu, or the reference implementation was like that, and not that easy to scale. So we, at the beginning, focused on Jitsi. So the first test, when we met, it looked quite promising. We had a handful of people who were quite pleased with the solution we had there. And so we thought of how can we scale that for more people. Maybe other people have the same issues as we have. So we wanted to have a platform where we can stay in contact, and others might have the same issue. And so we thought of opening it as well for the public. And especially schools needed such a solution, and others then came to us who wanted to use it. And so we kind of got confirmed that it was a good idea to open publicly. But if you start building something, you have to kind of consider that it's gonna use some resources, and so we needed insights, we needed some monitoring. How many users are on the platform? Which are the limitations? Where do we need to scale, or where do we focus on if we need to scale? Which are the bottlenecks? And so we set up a monitoring stack, including Telegraph, InfluxDB, and then Graylog, as you can see down below. And so we found out the key metrics, and we found out where we need to focus on for scaling. And Annika, especially, and some others of our community had contact in the industry, and so they asked them if they might support our platform. And in the end, they were a bunch of people and companies who are providing us with servers so we can run the infrastructure. So now we got the power to actually run it, and now we then went to the local press. We went to Bayern, BR, Digital Crush, so some press sites. We gave some interviews, so people are invited to join our platform to use it. We focus on a private sector, so especially the people who kind of don't have the money to build up on their own. We appeared on several public server lists, and so we saw it growing. And then at the end of April in Germany, the school started again, and this, yeah, we could notice that in our monitoring. Before the school started, we had a peak of around 600 people, and as the school then started, again, we saw, yeah, much more people. We saw a peak in the morning, so that when the school started, they we have here the high amount. Then during lunchtime, there are not many people in the afternoon, especially the public people. And this kind of grow over time. And we can see here the weekends. Then there is no school. People are using their local contacts. And so we can see this in a drop in our graphs. So looks good, doesn't it? Some things went then unexpected or differently than expected. Monitoring revealed that especially schools use that, as I said before, but not only schools in Germany, but as well off-road. You can see the image on the right side, 35% at that point of the users were coming from Peru, which is kind of on the other side of the world, but somehow they are repeatedly using our platform for that. Small companies are using it. We hosted some open source communities, and they use our platform as their primary system. What we noticed then that some people got blocked, some issues were there that they could not see each other, and this happens if people are behind firewalls, netting, and the like, which is then blocking the traffic from going through, especially UDP traffic is blocked, and there we needed to implement Turn as a relay system. And what we then did for optimization, we enabled BBR as congestion control algorithm, which kind of enhances the situation. But yeah, so we had this, and it went better for a lot of people. But there we then faced different issues. But Annika will tell about this. Annika, your mic is muted.
No. Now I'm unmuted. Hi everyone, I'm Annika. I continue this talk with some pitfalls we stumbled across and also the architecture and how it evolved over the time. So first pitfall was we set up multiple turn servers, as you could see in the picture before, but only the first one was used. The code you see below is actually from the WebRTC implementation of Chrome. So the first server in the list always gets the highest priority and is always selected as the primary turn server, which is used by all browsers. So basically our first turn server was always selected by every browser and just got all the load. And it only failed over if we had it in maintenance or whatever. So we actually fixed this by randomizing the sequence in Jitsi so that it just spit out the turn servers in different order, and this then helped that it actually spreads the load, which you can see here, and then starts using the other turn servers. So as we saw more records, we also saw more bugs in our stack. So it happened that a main component of the whole system crashed, and because of the crash and all users reconnecting, we got another bug, and this kept on going, and we weren't sure how to fix it the first time, but thankfully it was open source, so we could look at the code. And actually, we looked at the code and deployed a fix in under 20 minutes to actually get out of this situation where the whole system overloads. Then all users get again disconnected, and this kept going and going, as you can see here. Unfortunately, there was also then a crash in the local user databases. So it took a bit longer to actually fix the whole problem, but we also had good contact to everyone in the open source community, especially Prosody, which was one of the components who had the database problem. We talked with one of the developers, and they said how to fix it. Basically, it was just rename the DBs and go from there, start from scratch. So as we run on virtual machines mostly, the least machines, I think only 3 of them are really bare metal systems. Everything is VMs. And as you can see, we run many packets per second. It's up to 100K packets per second for some VMs when there are really, really many users. So this is a problem for virtual environments, especially if you are on an oversubscribed host, which already handles lots of load. And then we come and put up to 1 million interrupts per second onto this machine. Or even if both machines are, or many video bridges are placed on the same host, which happens in some cloud environments, then you see spikes and everything gets slowish, and it's a real big problem. So Jitsi has a load balancing architecture, but the problem is it's using fixed values. So it's just using 58K packets per second as the base, and calculates that through the actual packet rate download and packet upload. It's then divided by 58,000K. And then basically, yeah, this is the load. This is a stress value. It goes to 1. It's basically the bridge is now fully loaded and shouldn't be used anymore. But as I said, it's a fixed value. So it works on the assumption that an 8-core VM at AWS can handle this load. We were not running on AWS and not always on the same provider. So yeah, we had issues with that. So this was our first approach on the whole infrastructure. As you can see, we have this signaling node I talked about, which handles the load balancing and everything towards the video bridges, or media nodes, which we call them here. The media nodes at this point didn't talk to each other. So basically the users just connect to one video bridge and that's it. So also this means that you cannot scale a conference bigger than what one video bridge can handle. Well, you can theoretically, but then you're stuck because you cannot handle the load anymore. But we already automated this in a simple bash script at this time, basically, because we didn't want to put our salt master, which we have for the other infrastructure on the internet, which was a good choice because like 1 or 2 months later, there was this big salt 0 day, which exploited basically every salt master. So then it happened, people asked for bigger meetings because one video bridge can handle up to 75 users in one meeting, especially with video on. So we needed a solution for this. And if we go cross video bridge meeting, if we have a meeting which goes cross video bridge, and there's no encryption between video bridges. So the whole video stream wouldn't be encrypted if we do this. And as we have multiple data centers, this would be a problem. So we would then send all video streams unencrypted between 2 video bridges. So we needed a mesh VPN, basically a full mesh VPN, because we didn't want to have one point where all traffic has to cross, but basically a full mesh, so it could handle the load and everything. And yeah, so this is when basically we enabled Octo, which is the protocol for cross video bridge conferences. You can see it had quite an impact. We run 400 Mbits between the video bridges, and it's compressed, so it's not per participant. There's not one stream between the video bridges, but it's one stream for all participants between the video bridges. So you see that basically the load really grew on all these machines. Many are handling stress of 1, and their Octo starts and everything gets split over different video bridges, and they kind of handle the load together, and not only one bridge becomes overloaded. And people actually really used it. We then saw meetings up to 100 or 120 people. So this is then how the whole platform evolved. We put everything into Nebula. All the video bridges are in Nebula now, and connect via an overlay network. Yeah, that's basically how everything changed, and you can now talk between the video bridges fully encrypted.
Just to let you know, Annika, you've got 5 minutes now remaining to include questions. So are you wrapping up?
That's the last slide. So basically, those are some figures. We just wrote them down. I think they are quite impressive for an open video conferencing system which started from scratch. And yeah, just to have a short overview, I'm not going to read them out. So thank you everyone for giving us the time to talk to you, and especially thanks to our sponsors who helped making this possible. So I hand over.
Thank you, Annika and Matthias. Okay. We have one question for you. What is the funding model for your platform? We have this question from Keith Mitchell.
So basically, we just approached vendors and everyone to get resources. So the whole model was hopefully someone will help us getting to run this platform. There's no special. It was basically put up to help people fast. So there was no special plan at this time. We just needed resources fast, and I approached many of my friends from the industry, and they were everyone was so helpful because it was for a good case. And so yeah, there's no special model behind this at the moment. We are just trying to put this up and wrapping it up and how to run it for actually years, and not just during COVID or during the start of COVID.
Okay, thank you for that, Annika. We currently do not have any more questions. If anybody would like to submit a question, we still have a bit of time.